If you're still struggling with some of the basic word problem translations, let's go through here, and I want to just sort of give you some information that you might be able to use, some terms, key terms that we might need to remember, just some basics, and then I'll also go through and do a couple of the problems in the homework for you. Okay, so some things that we need to remember just in terms of key terms and how we translate them. For example, if we read something that's talking about a number, okay, we need to know that we are going to replace that with some type of variable, whether that's X, Y, T, W, and because we're looking at systems today, that means there's a couple of things we need to keep straight in terms of having two variables. So when there's two variables happening, we'll either be talking about something like a first number and a second number. Okay, which means we need to replace these words with two different variables. So we would need to assign some letter to a first number and something to a second number. Okay, they just can't be the same thing. Or we might read something that says a number, and then that says another number. Okay, it being another number means that we need to also assign it a new letter. So if we assign a number to X, when it's asking for another number, that means that needs to get a separate variable. Okay. We should know some basics like is going to tell us to use the equal sign. We should know our basic terms of sum is telling us to add. Difference is telling us to subtract. Product is multiplication. And quotient is division. So I'm writing this division sign to represent division. Remember, most of the time when we're writing division, it's going to be way easier to put that in a fraction form. There are also things that we should know, like more than is telling us to add. If we read addition, addition is telling us to add. Of is telling us to multiply. So if we say like half of something, that's telling us to multiply. The big one that we need to make sure is that we have less than and subtracted from. These are both things that tell us to subtract, but we have to remember if we read less than or subtracted from, this is telling us not only to subtract, but also to change the order. So if we read something that says 4 less than a number, right? It's true that for 4 we're writing 4, for less than we're doing subtraction, and for a number we're putting a variable. But less than tells us to flip-flop or swap that order. So what we would actually write down is x minus 4. So now that we know some of these key terms, or at least we're reminded of these key terms, we then want to apply that to what we will do with a system. So when we're looking at basic word problems with systems, now when we translate, we're going to get 2 equations and 2 variables. Okay, we're going to use those same key term translations that we just talked about. We just want to end up with 2 equations once we translate it. So this problem is asking us to find 2 numbers. So we know since we're trying to find 2 numbers, that means we need to have 2 variables. So you can decide what letter you want to use, but since we've been sort of using X and Y the most, that might be the easiest way to make this first transition. So we'll have a first number, maybe of X, and a second number of Y. Now it's telling us to find 2 numbers whose sum. So if we go back to the things that we wrote down as our key terms, sum is telling us to add. Okay, so that's telling us that we need an addition sign. Okay, and it's the 2 numbers that have a sum. So that's telling us we need to be adding the two numbers that we created. Since we don't exactly know what numbers they are, right? We replaced those numbers with letters, saying that we don't know what they are. So we're going to add up x plus y is, right? We said is tells us to put equals 64. Okay, and now says and. Right, when we're writing a sentence and we use the word and, what we've really done is we've taken two sentences and we've pushed them together. Right, so we could really talk about this as find two numbers whose sum is 64, and then find two numbers whose difference is 42. Right, we're sort of treating that as a separate sentence. Because it can be treated as a separate sentence, that means we need to start a new equation. So this first equation is done. We now need to start a second one. Okay, so this one says find two numbers. So our two numbers, right, we're representing with x and y, whose difference. So again, if we look at our list, difference is telling us to use subtraction. So we're going to subtract x minus y is equals 42. Once you get everything translated, at this point, you're now just left with something that you need to solve by solving a system, which means we have choices of solving by graphing, solving by substitution, or solving by elimination. So some of you might choose different options of solving based on sort of what you prefer. This problem is already pretty nicely set up for elimination. Everything's stacked. Right here in front of the y's, they both have a coefficient of 1. Where this is a adding one and this is a subtracting one, so we have a positive and a negative. So we can just straightforward go to adding these straight down. X plus x is 2x. My y's are going to cancel. 64 plus 42 is going to give us 106. Okay, this is then a one-step equation, so we can just go ahead and solve. We'll undo multiplication with division, dividing by 2. And we'll get x equals 53. Now, we're not done because this problem said to find two numbers. Not only should we know when we're solving a system, we need both the x and the y, but this problem says to find both of them. So we're going to need to plug this back in. Right? You can plug back into either the top or the bottom. I'm just going to choose the top, and I'm plugging it in for x because that's the variable I found. So I'll now say 53 plus y equals 64. I can solve this by subtracting 53 from each side. And I'll get y equals 11. Okay, so now I have my two values. In the past, we would say, okay, we've solved a system, x equals 53, y equals 11. But this isn't asking us to solve a system. This is asking us to find two numbers. So what are those two numbers? The two numbers are 53 and 11. Okay, and that's how we'll write our final answer here. Okay, so let's also take a look at number 3. Number 3 says 3 times one number added to 5 times, oops, that should have an S, another number is 14. Okay, so we see the period, the end of the sentence, so that's going to be our first equation that we want to write. So if we go through and we break this down, 3 times one number. Okay, so hopefully you know that 3 is multiplication. One number, we said that we're going to assign a variable to it, so we have 3x added to, add 5 times another number. Okay, so 5, I'm multiplying times another number, so I need to use a new variable. Is tells me to put equals 14. Okay, the end of a sentence, so that's the end of that equation that I need to write. Okay, so now I'm starting a new sentence, so I'm going to start a new equation. So twice the first number. Now, this doesn't mean take twice times the entire 3x. It says to take twice times whatever variable we picked first. So we picked x first, so we're going to say 2x minus, so subtraction, 5 times the other number, 5y, is equals 1. So I'm actually not going to solve this one for you right now. What I want you to do is finish solving this on your own, and then go back and try and write an equation and solve number 2 on your own. And then when you're finished doing that, go ahead and watch the follow-up video and check and see if you're correct.